All right, hey workshop students, if you're following along, I've said I would make 3 videos, each for each of these problems. Somebody was asking about why they missed that and how they can do better in the future. So good growth mindset, always good to have that growth mindset, and we can get better and better. And I would try to illustrate in the number 3 and number 4, and we'll again here in number 5, that you need to follow these 4 steps. Good physical picture, free body diagram, write out the equations, solve. Okay? And I will follow those same 4 steps here. So if you saw the second video here on number 4, that was the answer we just did. So let me move on and say, all right, week number 6, this is the quiz, and let's look at number 5 here. All right, so number 5 here says, in the image shown, the child has a mass of 19.4 kilograms. The chains each have a length of 2.8 meters. As the child swings, she moves along a path which is part of a vertical circle. When the child is at the lowest point of the swinging of the path, the chains exert a total upward force of 398 newtons. What is the child's speed in meters per second? Okay, and then note speed is a positive number. All right, and it looks like this person got it wrong, and it looks like we're shooting to try to find that one. But I'm going to start off again like all of these, and I'm going to say, hey, get a good physical picture of what's going on. And in this case, I don't think this is good enough here. Number 4, I said this was a pretty good one to kind of imagine what was going on, and I could draw right on it. But I'm going to just start anew here and say, okay, if this is where the chains are tied to, they drop down 2.8 meters, I believe I read. Yeah, 2.8 meters. And so here then is the child, and of course always being 2.8 meters away would make an arc that's part of a circle, and as your author describes it, a vertical circle. This being the center of the circle, and the fact that it moves in a circle is going to have that whole centripetal acceleration, centripetal force issues come into play, and so the child's going to be swinging back and forth there. Okay? And so I hope I'm done with step number 1. Okay? Got a good physical picture, child swinging at a set distance, making an arc. They're asking something about at the lowest point. So then I'll go on to step 2, which is the free body diagram. And so I'll draw the child, kind of a boring picture of the child. I get it. But as I like to say now, look at all the forces on the child. And I like to say one of them, and the easiest one, is there's always going to be the force of gravity, mg. Draw that one first, draw it down, and then look for everything touching the child. Now, in this case, what's touching the child is the swing/chain configuration. And then technically there's 2 chains. Looks like in the picture, technically there's a little board that the child is sitting on here. But taking all of those as one unit, because that's what it says, the total upward force. And so this force is kind of one big force pushing along the chains, and so I'll just call it a tension in the chain. Although they do give me that number, so maybe I'll put it in my diagram of 398 newtons. They also gave me the mass of the child. Put that in my diagram as 19.4 also. Okay. But the numbers aren't real important in this free body diagram. In fact, sometimes they make things worse because they just make it cluttered. And the whole idea of a free body diagram is to make things a little bit simpler. So you don't have to look at anything else but the object. And then the forces. And you don't even really need to look at whether it's a chain or whether it's a board or whether it's a gravity or magnets. You know, none of those matter. Just is a force. But I think I covered step 2 well. Free body diagram. It's the force of gravity and everything touching it, and what's touching it is just the swing. Okay. So then I go off to, as you probably saw in the other two questions on this quiz, and any of my other videos, I like to say divide your paper into two, X and Y, because this is what I mean by adding up the forces, is to put them into this equation. This is the step 3. We're going to write out that equation. But part of writing out the equation is deciding which components are X and which components are Y. So I need to make a grid. And so I've been doing that in green, and I'll keep doing that in green. And my recommendation was to make the X-axis, or one of the axes, in the direction of the acceleration. Again, this is where a little bit of knowledge about circles come into play. So maybe up here in the top corner, I'll review that if an object goes in a circle, no matter where it is, say right here, the acceleration, the centripetal acceleration, the v squared over r is towards the center of the circle. So in a problem like this, we have to go back to the very beginning step and recognize that I have something moving in a circle. And the center of the circle is upward. And so the acceleration is going to be v squared over r upward. And like I said, I think it's best to choose one of your axes, either X or Y. I've been saying X, but maybe this time I will do Y as the vertical in the direction of the acceleration, because it matches traditional Y. And like I said, the only thing I really want to do is make sure the acceleration is along one of my axes. And here's why. I guess I didn't explain why that is to the advantage in this video. I've done it in the other videos, but here is why, is if we set one of our axes, and in this case I'm going to do the y-axis, then this just becomes an acceleration without a subscript, without a cosine or sine. It's just, hey, this is the acceleration. And the other one then becomes 0. There is no acceleration, perpendicular to that axis, because you made that axis in the direction of the acceleration. And that's the real advantage right there. That one of your equations, and this time it's going to be the x. The other two ones, I did it the other way around. I made the acceleration in the direction of the x-axis, so the y was 0. But on this one, since the acceleration is towards the center of the circle, which is up, I'll make that the y-axis, and because, like I said, that's traditional. And it's also what I'm shooting for. So I'll have the advantage of both of those. Now, in this case, I'll even go one step further. The acceleration towards the center of the circle is v squared over r. And in this case, the r is the length of that chain. So that's why coming back to the step 1 is very useful. Okay. And so now I can just figure out what the forces are, and I can then just look at them. And so if I look at, say, the tension force first, I would say the tension is all in the y direction, and it's in the positive y direction, and nothing in the x direction. And then if I look at mg, that's its weight going down. Oh, I guess I didn't draw an x direction in my diagram. But once I chose the y, the x has to be perpendicular to it. And I'll make, again, the positive towards the right like tradition. I guess I could have made it that way. But I don't see any purpose of doing that. So I'll stick to the tradition. Okay, so I'll say it again. The tension is all y and no x. And then the mg is, again, all y. It's actually a negative y, so it's a negative mg and nothing in the x. Oh, by the way, notice that for the x, this problem's kind of boring. It just says 0 equals 0. So very true, but not very useful. What is it? True, but useless. TBU. So that's a little TBU problem right over there. True, but useless. All right, now over here, then I think we can now begin to solve this, because this problem asks for the speed, and that means I would need to know these other pieces, and I do. And then I can solve for the speed. So I would say at this point I'm done with step 3. I just wrote out the equations, and then step 4 is solve. And this one's pretty straightforward in solving. There's no coupled equations with the x. It's just all y. Whereas if you watch the last video, I did more than we needed to do, but we could solve this for normal and plug it in, and so we've got these coupled equations with a normal component on each side, and we can then figure out, say, the velocity, if that problem had gone that far. But this problem was just asking a little bit about the normal force. All right, so now I'll put my numbers in here. And so the tension is the 398. The mass is 19.4. G is 9.8. Again, the mass is 19.4. V squared over the R, which, again, the R, we got to kind of deduce from the length of the string, the length of the chain, 2.8 meters. And probably didn't give myself too much work, but I think I can just squeeze it in here. 398 minus 19.4 times 9.8 gives me 207.88. Over here I'll take the 19.4 and divide it by 2.8. And so that is 6.9. I'll go 3v squared. So maybe I'll come up here and take that number and divide it by that number, copy and paste. So that's velocity squared. Taking the square root of that, I get velocity is 5.48. Yay! And good, does match the computer's answer, 5.48. All right, hope that helped. And like I said, follow those 4 steps and you can do all 3 of these, all the quizzes, all the problems, anything involving motion. That's the lesson. That's the beauty of the physics. Physics is about knowing how to use a few but powerful fundamental concepts to explain a universe of phenomenon. And now with Newton's laws, we could do the motion as small things like molecules, or medium-sized things like cars, or gigantic things like galaxies. All right, take care.